So now again, we will see the derivative of a function and also the tangent line of a function, how to find it and what is the simplest way, okay? So for example, here is a point A, and we have to find this is 3,9, right? So we have to find a derivative at this point, or we have to, that means, so derivatives means the slope, okay? The slope at this point. So to find the slope, we can think that a point nearby here is P, and this point is approaching to a point, okay? So here is our x. Here is the value s, and this value is approaching. This value is x1, okay? This is our x1. So this x1 is approaching to like 3, okay? This x0. So we can write, we can say that when this value of h is approaching to this point, this x0, then our slope will be del y by del x, okay? And del y is y2 minus y1. So here it is 2 minus 9. So here you can see our this is our y2. This is our y2 and this is our y1, right? And we can just call this x0 as x2, okay? This is our y2. This is our y1. And this is our x2. And this is our x1, okay? So why this is x1, y1? Because this was our first, this A was our first point, right? This A was our first point. So that's why it is x1, y1. And we just imagine this point P, right? That's why this x2, y2. So now if we find the slope del y, that will be y2 minus y1. And del x will be x2 minus x1, right? Now you just minimize this, you just put the value. So it will be h square minus 9 by h minus 3, okay? And now you can factorize this function, this numerator. Then it will make h minus 3 into h plus 3, right? Because this is a square minus b square. And we know a square minus b square is equal to a plus b into a minus b. And we have h minus 3 as a denominator. So we can cancel this h minus 3, and then we get h plus 3. And this h plus 3, now we have to plug in the value of h. We already know that h is approaching to 3, right? H is approaching to 3. That means here h will be 3, okay? Like when we write this way, limit del x tends to 0, right? Or del x tends to something like 2, okay? So this way, that means we just plug the value 2 in our function, right? Do you remember? So as this P is approaching to A, that means this H is also approaching to this 3, okay? As this P is approaching to A, that means this H is also approaching to this point, okay? That's why we put H equal to 3. So we have 3 plus 3 is equal to 6. So this 6 is our slope, okay? You can see here, this 6 is our slope. And we now we can draw our equation. Now we can find our equation. Because we have a slope here, 6, and we already know our point, right? 3,9. So now a slope at this point A. A slope at this point A. So this will be just y minus y1 is equal to m into x minus x1, okay? This is our point slope equation. Do you remember in our previous lecture lesson, our Laoshi told us about point slope equation?
Yes.
So now we have to plug in the value, like this is our y1, our x1, and our slope is 6, right? So
Yes.
it will be y
minus
9 is equal to
9 equals to
6 into
6.
x minus 3. Okay. So if you simplify this this form, it will be y is equal to 6x minus plus 9 minus 18, right? So it will make minus 9. Right? So this is our this is our tangent line, okay? Plus 9 and 18, okay. So this way we find the derivative and tangent line, okay? So let me show you in a graph. So our function was what is the problem? Why it is not coming down? Okay, so our function was y equal to x square, right? See here, our function is y equal to x square, and our how that is called?
Equals to y.
Our tangent line. Our tangent line is y is equal to 6x minus 9, right? So this is our tangent line, and this is our function. This is y is equal to x square, and tangent line is this way, this line, right? Okay, y is equal to 6x minus 9. So now we can graph this. Here y is equal to 6x minus 9 and y is equal to x square. So what was our point? Our point was 3,9, right? See here, our a point was 3,9. So now we just found the tangent line at this point 3,9, where our function is y is equal to x square. So this is our graph, okay? You can see x is equal to 3. That means x is equal to 3 will be here, right? This is our 3. So if you go to y is equal to 9, so it will be somewhere around here, right? This is our right. You can see here y is equal to 9 and x is equal to 3, right? And here our function and the tangent line, this is intercepting. If I zoom in, you can see here, right in this point. So this graph is clear, like this purple line, this violet line is our tangent line, and this green line is our function. That means we found the right slope, right tangent line for this function. Okay.
Okay.
So this is a simple example of finding a derivative and tangent line. Derivative is our slope. Derivative is our slope, and tangent line is just we just find the slope, and then we put the value of slope here in this point slope equation. Okay.
Yes.
And then we find our tangent line.
Tangent line. Okay.
For this 3,9 point. So the definition. the tangent line through a point A is the line that passes through A. You can see our line is passing A, right? So this is our A point, and our tangent line is passing through A, right?
Yes.
And whose slope is the derivative at A? Because we already calculate the slope here, 6, right? And we didn't find the derivative, but this 6 is also the derivative. So let me show you. Our function is y is equal to x square, right? So if I just make the derivative of this function, so it will be 2x to the power 2 minus 1, right?
Yes.
According to our formula. So it will be 2x. And now plug in the value of x. We know that value of x is equal to 3, right? So here it will make 2. It will be equal to 2 multiply
by 3.
This will be 6, right? So this is the easiest way to find the slope or the derivative. So, or you can just find this way also. So this way is to make it clear, like how does it comes, okay? This is the explanation, and this way, and the way I just showed here. So this is the way of making that. This is the simplest way, like the mathematical way, okay? Now let's go to our note, like what our Lausi told us. So here is our Lausi draw a graph. So maybe I already explained it. So this is our oh no. So this is our function, and for this function we have 2 points here. Here is point A, and here is point P. Okay. So as like the same example before, this P point will approach to A, and then we will find the slope, and we will find the again I forgot this. Then we will find the tangent line. Okay, tangent line. So this is the basic theory. If this is a function y is equal to f of x, and we just take 2 points. One point is here. This is A, and this is A, and another point is here. Okay, this is P. And if this value of P approaches to A, then we find the slope, and we find the tangent line. Okay. Basic theory. Now, okay. Now just let's put these things in here. So we know that this value will this P will go this P will approach to A, right? That means what is the coordinate for this P? This is P and this is A. So coordinate of this P will be the value of x and f of x, right? or value of x and
Yes.
y. Okay.
Okay.
Can you see these small dots?
Mm-hmm.
So using these small dots, I just show the value of x and y. Okay, for this coordinate, for this coordinate p. So this is x naught plus del x. This is our x, and y will be f of x naught plus del x. Okay, and this coordinate, this point will be x naught comma f of x naught, right? This will be x naught comma f of x naught. So now our slope will be y2 minus y1, right? Y2, this y2 minus y1 by x2 minus x1, right? So if we just calculate the slope, this will be this way: y2 minus y1 by x2 minus x1. Okay.
Mm-hmm.
So you can just calculate this x2 minus x1. It will be x naught plus del x minus x naught. So x naught cancel. We only get del x, right?
Yes.
And this minus this makes, this is already written here. This is y2 minus y1. Okay. So this way we represent a graph using limit. Okay.
Okay.
And this is f of x naught. Maybe I have written the definition somewhere else also. Here you can see, this is the definition. So f of x is equal to, if x tends to x naught, f of x plus del x minus f of x by del x. So these things is all similar like the, here again, you can look at this function. This is the main definition. Okay. This is the main and the longest definition. So we already calculated this value, right?
Yes.
We already have seen this value from our graph. So and we and this is f dash x. So this dash means derivative, right? So if we derivative the x naught or the function, so we get our this slope. Okay, we already know that this is our slope m. So and that also means del y by del x. Okay, and del y by del x is also means slope, right? And this f of x naught plus del x, this is f of x. So how do we find this f of x? So we have here, we find this using left hand limit and right hand limit. Okay. No, we don't need this. For example, here we have y is equal to f of x, a function. Here is a function y is equal to f of x. And now this is our slope. And how do we find the slope? If we differentiate the function. Okay. If we differentiate the function, then we find the slope. And now this is this slope is this function, right? We have already seen in the graph. And if that is the case, then this is del y and this is del x, right? I have already shown these things here. Okay, so this part is similar to this part. This is our del y and this is our del x. And f of x, this will be f of x, this will be f of x naught plus del x. Because if you just keep x on the left side and this on the right side, okay, that means you just take this x naught from right to left, and then you get x is equal to x naught plus del x. That's why I put it here. Okay, this value I put it here. F of x naught plus del x minus f of x naught. If the limit exists, it is the derivative of the function at the x0 point. Okay. So do you understand the main definition? Or just can you just feel the main definition? What is the main definition? The main definition is, if we differentiate a function, so we will find the slope, right? That means if we derivative a function, then we will find the slope. And using that slope, we can draw our tangent line. Okay, at a specific point.
Okay.
And another important thing. So if left hand limit and right hand limit is not the same, then we cannot find the. For example, here we have f of x is equal to absolute value of x. This is not differentiated at the origin, so it is not differentiable here. Why? Because you can see the right hand limit and left hand limit, both are different. So if they are not the same, that means this function is not differentiable at 0 point. 0. So how do we find this 0 point? Okay, so you can see our value of x is 0, right?
Yes.
And if you put this value of 0 here in the right hand limit, so it will make 0. So if x is 0, y will be also 0. And if you put the value of x here, so if x is 0, then y will be minus 0. So minus 0 and 0 is same, right?
Yes.
So this way we find this 0 point. So this function is not differentiable at the point 0, 0, because at this point our right hand limit and left hand limit is not the same.
So if it was, okay, let me say, if it was 1 and 1 and not negative 1.
Sorry?
The left hand derivative, it's negative 1, right?
Let me show you. So
if it was not negative 1 and it was the same as the right hand derivative,
then we could then this function would differentiable at 0, 0 point. And then find the slope and our tangent line. Okay, so here in this point, in this 0, 0 point, we cannot find the tangent line. Okay, because this value doesn't exist. Okay. Okay, now if this was 1, like if left hand limit and right hand limit were the same, then we could find the derivative and tangent line. So how this is on and this is minus 1. Okay, you can have a close look here. For f of x is equal to modulus x, we have two values. So here it will be x when x is greater than 0, and it will be minus x when x is less than 0, right? So and from the middle part, you can see x is equal to 0, right? So if you input 0 here, so not 0, this will be 1. X is greater than 1. Oh yeah, we do not just input 0 here. We think it using the limit. Okay, so you can see here the little sign here. This sign is called the derivative sign, right? So this means ddx of x, right? And according to our formula, ddx of x is equal to 1. Okay. Can you remember?
Oh yes, I'm still here. Yes.
So you can see here, and a derivative of a constant value is 0, but derivative of x is equal to 1. Okay.
Mm-hmm.
So this
Equals to
way
1.
we found this. What is that? This way we found this 1 and minus 1. Okay.
Mm-hmm.
That means our left hand derivative and right hand derivative.
Okay.
So it means like a point is approaching from left to 0 point and approaching from right to 0 point. Okay.
Mm-hmm.
Then our slope is, if this approaches from the right side, so our slope will be plus 1, right? And if it approaches from the left side, then our slope is minus 1.
Minus.
But as they are not the same, that's why we cannot find the tangent line.
Okay.
At this point, okay, at this 0, 0 point.
Okay.
Because both of them are approaching to this 0, 0 point.
Can you make a different example whereby it does not specifically say it approaches 0, but it approaches a different point and we
Yes,
find
yes, I can. Yes, I can. Yes.
Okay.
Let me show you. For this equation, we have f of x is equal to x cube. So we have to find the equation for the tangent line at the point 1, 1. So here x is approaching to 1, okay? So if I graph this, so it will be f of x is equal to x cube, right? Remember, so you have to compare this with this line, okay? Like when p is approaching to a, then h is approaching to approaching to 3, right? So can you remember the first example I gave you?
Yes, yes.
Okay, so you have to think this function as like this way, okay, to understand that how this a is approaching to 1. Like you can see x is approaching to 1, okay? Sorry, this is x naught. X naught is approaching to 1. What was the this was the previous example? Here x is equal to 0, right?
Yes.
So here our x is equal to 1.
Equals to 1.
X equal to 1, okay? We can also say this x equal to 1, okay? X equal to 1. Or this is x approach to 1, okay? So now let's graph this. So if we graph, you can just understand f of x equal to y equal to x cube. Y equal to x cube, and the tangent line y is equal to 3x minus 2. 3x minus 2. So if where is our point? Our point is on comma 1, right? You can see here our point is on comma 1, right? So here in this graph, on comma 1 point is here. This is on, x equal to 1 and y is equal to 1 here, right? And you can see our tangent line is touching this point, this on comma 1 point. This is not intercepting, just touching. And here is for this tangent line we have a slope. So let me draw this same thing in our, this will be like this way, and okay. So our graph was like this. And it was coming and just, okay. Just coming, then it will make something like this and goes up. Okay, like this way, right? And here is our on point, for example, here. And our tangent line will be this way, right? Okay, so we have a little graph here, maybe not so good. X and Y. And so now our X is approaching to 1, right? So X is approaching to 1. Can you see here?
Mm-hmm.
What lesson? Yeah, sure.
Okay. Oh no. This is like this way. Okay. So here X is approaching to 1, and this is our on, and this is our 1. Okay.
Mm-hmm.
So what was our previous example? Here X was 0. So now our X is equal to 1. Okay. Now we have to see the left hand derivative and right hand derivative.
Yes.
So yeah. We do not have right hand derivative here and also left hand derivative here. How can
Okay,
I?
then when do we use them then? Because in this example, I see there's no left hand or right hand.
Yeah, maybe we have, but we need to find where this is. Like for this function, we had 3 functions, right? But here we have only 1 function. You can see here we have 3 functions.
Okay.
But here we have only 1 function.
Okay. Okay, it's not a problem. Then we can move on.
So this is our 1, point. If X left hand limit from left side and from right side. Let's see this. H is approaching to 3. And then we find our slope. Okay. And here, X is approaching to 1. And for this, we find our slope. Okay. So if we derivative this, so can you remember how do we find the slope?
Yes.
So let's not think about the left hand limit and right hand limit. Let's just solve this here. Okay. So we do not have like 3 functions here, as we had before, right? So that's why I am pretty confused that where is the left hand limit and where is right hand limit.
It's okay.
Okay,
so
so
we can continue.
now we already know that if we differentiate, if we find the derivative of this function, so it will be our slope, right? So now we find the derivative, and this is 3x squared. So we have to draw our tangent line at this point, 1, 1 point, right? So for this point, our x is equal to 1. Our x is equal to 1 and y is equal to 2, right? X1 is equal to 1 and y1 is equal to 2. Oh, sorry, y1 is equal to also 1. So now you plug on the value x is equal to 1 here, and you get slope is equal to 3. Okay? So the slope of this line will be 3. Okay. Now,
Yes.
now we have to find the equation for this line. So that is very simple. We already know the point slope equation, and we just plug the value m is equal to 3, and y1 is equal to 1, and x1 is equal to also 1. Okay. So that is y is equal to 3x minus 2. So I just make the graph here. Y is equal to 3x minus 2. Okay. And then again the graph main function, right? F of x is equal to x cube. This was our main function. So I already I also graphed this main function. Then we can see that our tangent line is intercepting the main function at on, on point, right? So this on point here, we have a slope. This slope is 3, right? This slope is 3. And the line is y is equal to 3x minus 2. That means our tangent line. So how can we draw this graph? So this was like drawn in a computer, but how do we find the value? Okay. So let me show you how can we find. So for example, how do we draw this graph? Okay. So if you plug a value x is equal to suppose 1, so this will be 3 into 1 minus 2. That means 3 minus 2. That is 1, right? So if x is equal to 1, y is equal to 1. So now put x is equal to 2 here. So it will be 3 multiplied with 6 minus 2. That is 6 minus 2. That is 4, right? So if x is equal to 2, y is equal to 4. And now let's put this 2 point in our graph. So on point will be here, right?
Yes. And
this
the
will be here.
second one will be...
And the second on 2, 4, this will be 2, 4. 1, 2, 3, 4. Okay. So it will be somewhere around here, right? So if I just make this line a little bit bigger, you can see like it is touching this line. Okay. It is touching this point. So this way our graph is drawn. Okay.
Okay.
And for this line also the process same. F of x is equal to x cube. That means if x is equal to, for example, we can start with minus 2. Okay. So we have f of x is equal to x cube. So let's start from minus 2. So it will be minus 2 cube. That means minus 8, right?
Yes.
So if x is equal to minus 2, y will be minus 8. Now let's plug 1. So it will be if x is equal to 1, y will be also 1 cube. That means 1. So we can get 1, 1. So if x is equal to 2, that will be 2 cube. That means 8. If x is equal to 2, y will be 8. So now let's put this 3 point in our graph. So it will make somewhere around minus 2, minus 2, minus 8. Minus 1, minus 2. And minus 1, minus 2, 3, 4, 5, 6, 7, 8. So somewhere around here, right? So we can continue this line like up to here. Okay. And now let's see, this was our point. Now put on, on. So on, will be here, right? Is here in this point. Okay. Can you see here? Okay.
Yes.
Now 2, 8 will be here. 2, 8 will be 1, 2. And 1, 2, 3, 4, 5, 6, 7, 8. Okay. Somewhere around here. So if you continue this line, it will be touching here. Okay.
Okay.
So this way we just draw our graph. So to make it simple, I just use my computer. Okay. Nothing more. Okay. So now, can you see some homework?
That's the homework. I haven't actually done it.
So you haven't done your homework, right?
Yes.
Okay. So let me start from the beginning. So
Okay, thank
homework
you.
was like we had to find some derivative, okay, of a function.
Mhm.
For example, we have here y is equal to 6x squared minus 10x minus 5x to the power minus 2. So you can see here is on function, here is another function, and here is another function. So we have three functions here. So let me remind you some formula. Here is some differentiation rules, okay? So if two function is like this way, that they are sum, okay?
Mhm.
So this will be now we will sum them separate way. Like we just differentiate this function plus we differentiate this function, okay?
Okay.
So to make it to write it simple, u plus v derivative will be derivative of u plus derivative of v, okay? This is the simplest form to write them. And if this is minus, then it will be minus, okay? So this is called the sum rule. And number two, we have product rule. So if they are like this way, like they are multiplied, okay? U multiply
Yes.
v. So there will be, firstly we have to find the derivative of u, and we keep the v, plus we keep the v, and sorry. So it will be, firstly we differentiate u, or we derivative u, then we keep v, then we and plus we keep u and we derivative v, okay? You got it?
Yes, I got it.
Firstly you have to derivative, firstly let's say you keep u, so this will be v, this is not u, this is v, okay? So firstly you keep v, then you have to derivative the another function, that means u, and then no, this is v, okay? This is v. So we keep u and we find the derivative of v, and then we keep v, and then we find the derivative of u, okay? So to make it simple,
Okay.
u multiply v derivative is equal to u derivative v plus u v derivative.
Okay.
And here is a and if any of them is a constant value, like if u is a constant value, so it will be we just this function makes 0, okay? Because you already know that the derivative of a constant value is 0, you know,
0.
derivative
Yes.
of c will be 0. So so these things will make 0, and 0 into a function, this is also 0, right? So we only get this thing. So that means if there is something like 2x derivative of 2x, okay? So you can see this 2 and x is multiplied, right?
Okay.
So it will be,
and 2 is constant.
2x derivative. So 2x derivative. So that will be 2 into x to the power 1 minus 1, right? So that means 2 into x to the power 0. And x to the power 0 is equal to 1, okay? 2 into 1. That means 2. So you can see here, if this is something like 2x squared, so then what will happen? Then it will become 2 into x to the now we have to find the derivative of x squared, right? So it will make 2 into x to the power 2 minus 1. So it will make 2 into x to the power 1. That means 4x. Okay?
Yes.
So this is the product rule. Now let's see quotient rule. So quotient rule will apply when our function is divided, like f by z or u by v. Okay. If a function is like this way, u by v, then its derivative will be, firstly you just keep this b on the downside, this b, and you just make a square. Okay. So this b will become b square.
Okay.
And now firstly, for example, you can derivative u, then we will keep b and minus. Remember this sign, this is minus, but previously we had plus here, right? But now we have minus.
Why?
So as we derivative u before, now we have to derivative b, and we will keep u. Okay. So this way this is the quotient rule. Like you can see here, this is two function ddx of f by z. So we just firstly square the denominator, and then we keep our denominator, and we differentiate our numerator, and then we keep our numerator, and then we differentiate our denominator. So you got it?
Yes.
So now let's go back to our homework. So you already know that this is sum rule, right? So now we have to differentiate this one, also this one, and also this one. So this is our, do you remember, this is our second rule?
Yes.
So we have this is our this is called product rule. Okay, this is our product rule. So here you have to see we have a constant value here. This is 6. So this is, we will keep this constant value, and we have to differentiate this function, right? X square. So so x square.
Okay.
Yeah, if we differentiate x
X
square,
is constant, right?
yeah. So it will be 2 into x to the power 2 minus 1, right? So it will be 2x. So 2, and we already had 6. So 6 into 2 is this is 12.
This is 12,
this is
yes.
x. So this will make 12x. And here we have 10x. So again, same thing. We have to use product rule. So we keep this 10 here, and if we differentiate x, this will be x to the power 1x to the power here 1x to the power 1 minus 1, that means x to the power 0, and x to the power 0 means 1.
Okay.
Or simply the derivative of x is equal to 1. So it will make only minus 10. Okay. And here we have minus 5x to the power minus 2. So again the same thing. This is our product rule. So we will keep this constant value, and we just find the derivative of x to the power minus 2. So it will make n x to the power.
Negative, we still write it as a negative. That's negative 2x.
Yeah, negative 2x to the power negative 2 minus negative 1. Negative 2 minus 1. So can you understand this thing? Derivative of x to the power minus 2 is equal to minus x into x to the power minus 2 minus 1. This is the same rule, like x to the power n is equal to nx to the power n minus 1.
Okay.
So it will make 10x to the power minus 3. So you already know that we can write this. Right? Can you remember?
Are we supposed to write it like that, or is it optional?
Maybe it is optional. Okay, but this looks pretty good. If we write this way, it looks pretty good. So now here we have y is equal to 3 by x square plus x cubed by 3. So again, same thing, we will use our sum rule. But here, this is here, this part is like quotient rule, right? You can see here. No, sorry, this is not quotient rule. For quotient rule, we will find
Slow
two
down, slow down.
yeah, this is like simple, okay? This is not quotient rule. Quotient rule will be like this way, 3x by x square, okay? So if we here you can see our numerator and denominator, our numerator is a constant value, right? So this is not a quotient rule, okay?
Okay.
We can also use quotient rule here, but this will make a long line, okay? So we don't need to use that long line. We can think simply here. So if this is something like this, so if this would something like this, like here is a function f, and here is a function g. So then we would use to apply quotient rule, okay? But here we have a constant value, so we just keep the constant value below before, okay, before the function. And here we have 1 by x square, right? And we already know 1 by x square means x to the power minus 2. And now we got our product rule, right? You can see.
Yes.
So now we didn't apply our derivative yet, right? That means we didn't differentiated this function yet. We just rearrange this function, okay, in this line.
Okay, yes.
We didn't yet differentiate, okay? So now we will differentiate. So this is product rule. So we will keep this 3 here, and derivative of x to the power minus 2 will be minus 2 into x to the power minus 2 minus 1, okay? And this is also, you can see here, we have 1 by 3, right? 1 by 3. So we keep 1 by 3 out of here, and then we get x to the power 3, okay? So we have to derivative this x to the power 3. That means it will make 3x to the power 3 minus 1. Okay?
Okay.
The same way, like as we did here.
Yes, yes.
So now we will get minus 6 x to the power minus 3 and x squared. So we already know that x to the power minus 3 will be 1 by x cube. So in total, that is 6 by x cube, minus 6 by x cube. So you got it?
Yes, I got it.
Number 3, we again have our product rule, okay? So we have to differentiate this function, and we keep this, and then again we you can see here, we differentiate the first function and we keep the second one, plus we keep the first function and we differentiate the second one. Okay?
Wait, can you repeat that again?
Oh
We
yes, this
keep
is the product
the-
rule. Okay, this is the product rule. Here we have this is u and this is b, right?
Yes.
So this is our formula.
Okay.
So firstly, we have to differentiate one function and we have to keep another. Like here, we have differentiated this function. You can see here, we have differentiated our first function and then we kept our second function. Okay.
Okay.
Then
Yes.
then our plus the plus formula here. This formula, okay.
Yes.
And now we keep the first function and then we differentiate the second function.
Oh, okay.
Like firstly we differentiate on and then we keep another, and again we differentiate another and then keep
We
the
keep
first
the
one.
other. Okay.
So now we have to differentiate this, right? So this is you can see again sum rule, okay? We have x squared plus 1. That means we have to use sum rule here. So we have to differentiate this first and then we have to differentiate this, okay?
Okay.
So if we differentiate x squared, this will make 2x to the power 2 minus 1.
Yeah. Yes.
And if we differentiate a constant value, this will make 0.
Okay.
Okay, and then we keep this function here, and then again we keep the second one and we differentiate the first one. Sorry, then
Okay.
we keep the first one and then we differentiate the
We
second one.
differentiate the second one.
So it will make x to the power 3. So if we differentiate x to the power 3, it will make
That's
3x to the power 3x to the power 3 minus 1. And differentiate of a constant value is 0. Okay. And now we have to just this will make 2 to the power x. Okay. And this will make 3x squared. And you see, we just simplified. Okay. 3 minus 1 is equal to 2. Nothing more.
It's called 2. Yes, yes.
And now you multiply this 2x with x cube and also with 3. Okay. Because we have bracket here, so that means we have to multiply the outside number with
the outside number multiplies the numbers in the bracket.
Yes, with the numbers in the bracket. So it will make this way. Okay, this line. And then 2x to the power 4 and 3x to the power 4, that will make 5x to the power 4.
5x,
and then we have 3x squared here and we have 6x here. So we just keep it here. Okay, no change.
Okay.
And number 4. Firstly, we have sum rule, right? And then here is our product rule. You can see x and e to the power x, they are multiplied, right? And here is our quotient rule. We can see here there is no constant value, right? We have x by 4 plus x squared. So this x is not constant, and this 4 plus x squared, this is also not a constant, right? We have a variable here that is x. So now let's firstly differentiate this. Okay. So it will make if we differentiate this. So this is we will apply product rule. So that means we differentiate x and we keep e to the power x. And again we keep e to the power x and we differentiate. Then again we keep x and we differentiate e to the power x. You see here?
Yes.
We differentiate x and we keep e to the power x, and then we differentiate e to the power x and we keep x. Our product rule. And we will use the quotient rule on the next line, because if we do this in this line, so it will make a long line. Okay. So this line we used our sum rule and product rule. Okay, so now we will calculate this. Okay, or we will differentiate this. So you can see this is u by v, right? U by v. So this is our quotient rule. Our quotient rule is we have to make a square of this denominator, right? We have to write a square here. So you can see here. And on the upside, we differentiate first function, and then we keep the second one, and we differentiate the second one, and then we keep the first one. Okay. So then, if we differentiate x, it will be 1, and if we differentiate 4 plus x squared, it will be 0 plus 2x. So all in together, this is our final. This is our final result. Okay.
Okay.
And here is the important thing. If we differentiate cos 1, so it will become 0. Okay. If we differentiate cos 1, it will become 0. You can see here.
It's 0. Yes, yes, see that.
But if we differentiate cos x, if we differentiate cos x, So it will be minus sin x, okay?
Okay.
But if you differentiate just a number like cos 5, so it will become
Mhm.
0.
Oh,
Any number, it will become
it's
0.
still
Okay?
0.
Yeah.
Okay. Or same as a constant.
Like
it becomes
same
0.
as like constant. If you differentiate a constant, it will become 0.
It's 0. Okay.
So now we can see the last example. So here we have y is equal to x cube minus x square. So we have to find the equation of the tangent line if x is equal to minus 1, right? So you can see here is no point given. But you can just find the point from here. Like you just put the value of x in the function directly.
Mhm.
So you will get the value of y right here. We have x is equal to minus 1. Then if we value directly the value here in the function, then you get y is equal to minus 2, right?
Mhm.
Okay, that means our point is minus 1 comma minus 2. And now we have to find the tangent line, okay? So what is the process? Just differentiate this function. Just differentiate this function. Then you will get the slope, right?
Mhm.
So here I differentiated this function, and I got the slope
And
is
then-
equal to. Oh, then you just put in the last line you put the value of x, right? See here.
Mhm.
Then you get the slope. So if this point was not
Oh,
here,
when you're looking for the slope, then we have to substitute x with the
yes, right.
values of the coordinates. Okay, okay.
So if the point was like this, minus 2, minus 2. If the point was minus 2, minus 2. So then you had to put the value of x is equal to minus 2. Okay.
Okay.
That means the
Okay,
point was
okay.
here. Minus 2, minus 2 will be minus 2 here and minus 2 here. Sorry, minus 2
Okay.
will be somewhere around minus 1, minus 2, and minus 1, minus 2. So somewhere around here, right?
Mm-hmm.
So here in this point, our slope will be different, right? Because our input become our value of x become changes, right? So if the point is different, then our slope will be also different.
Okay.
So for this point x is equal to minus 1, comma minus 2, our slope will be 5. So now we already know all our information. We know our slope and we know our point. So we just use point slope equation. That is y minus y1 is equal to m into x minus x1.
Okay.
Just we plug in the value here.
5 and then
it will make y is equal to 5x plus 3. Okay. So this is our tangent line.
Why did you write plus? Because I see you wrote plus.
Where?
Is it plus 2?
Yeah, this is plus. Oh, okay. Let me show you here. So this is y minus y1, right? So this is y minus, and value of y1 is equal to minus 2.
It goes to minus 2.
Yeah. So this minus and this minus becomes plus.
Okay,
So we
I
get
get
y
it.
plus 2.
And
And again the same thing here. Minus and minus plus. So this way we find the tangent line.
Okay.
And remind a note that always the slope is the derivative of a function. Okay.
Okay.
Slope is nothing but the derivative of a function, or a derivative of function is nothing but the slope.
Okay. Okay.
So I think I covered everything.
Yes, you did. Thank you very much.
Yeah.
Thank you.
So I will stop the recording.